did hear a student say, okay, don't we, isn't this the table we make? So up here, I'm going to say start with y equals 3 to the x, and then you're just going to move it up 4 units. So, wait, so we can plus 4? Put in your backpacks. I'll hang out all the way in your backpacks. Okay, Sarah. I'm just going to start this table out. So you want to do for the exponent, negative 2, negative 1, 0, 1, 2. Plugging it in there. Graph that. And then to do 3x plus 4, you just want to move it up 4, right? So this is not the challenge. You guys can all do number 1. Number 2 is the challenge. So get to number 1 so we can hit number 2. Do your ball work, you guys. Do your ball work. Yeah. Yeah. It is.
Bro. I feel bored when I was over the board. It's not an atomic teacher. Anatomy?
I think she's still looking at it.
Well, it's not my business.
So stop asking questions.
I'm asking you.
I don't know the answer. I have no one. I can't think of it right now.
No. Hey, by the way.
So this would be 3 to the negative 2, which is 1/9. Well, this one's here. 3 to the negative 1, which is 1/3. 3 to the 0, which is 1. 3 to the first is 3. And 3 squared is 9. So that's your first table. Then in the problem, it's actually 3 to the x plus 4. So this plus 4 is a vertical translation up 4 units. So you can graph this and just count 4 if you want, or you could actually add 4 to these. I don't normally, 4 and 1/9. I'm going to write it 4 and 1/9. I don't normally do that. I like improper fractions better, but here it makes more sense. So if I add 4 here to make it up 4 units, that's 4 and 1/3. 5, 7, and 13. So that's our first graph. Going back to exponential equations and their graphs. We're trying exponentials to logarithms today. I think that's off brand. What?
Off brand?
Off brand. Yeah, it is. I know.
What does
I'm
that
sorry.
mean?
Can you please shut your mouth while I'm learning? Hey, I think you need some pockets of peace.
I don't even know what the heck that means. You gotta have a hot
Pockets of peace? Hot pockets have milk in it, buddy. You can't eat that. You'll die.
Yeah, I'll get whatever I want.
Huh?
Yeah, they do.
Hey, 1 day, 1 third, 1, 3, and 9.
We don't play this game this year. Like, do something important.
Yeah, I just hope you have a great day. Oh, okay. That's okay. I hope you care one day. Alright, so this is y equals 3 to the x. That's like the parent. And that up 4, I'll just count up 4 units.
She said it was off. I thought she was talking about like, it was just, yeah, they are. Target. Target.
So here it is. So that is the y equals 3 to the x plus 4 over units. Okay? So the real challenge is in number 2, finding the inverse of that equation. So I'm going to wait till you guys are done graphing number 1 to get to number 2. Maybe I'll put a big tip up here. So to find inverse, you switch x and y, then get y alone. So this is a past skill coming into play here with our exponential chapter. So I want you to find the inverse of y equals 3 to the x plus 4. That's the challenge. That's the challenge of today. This is the most challenging question today right here, finding the inverse of that equation.
Like how
Oh, you can do that. That's the easy way. Good job. Riley, you got lots of good ideas today. Okay. Yeah. Alright, so here we go. I'm gonna go to work and switching x and y and getting y alone for number 2, find the inverse. Were you able to get all the logic questions? Yeah. You all set?
I mean, be serious.
Okay, so here we go. Put the x here. Put the y here. Then I need to get that y alone. So I will subtract the 4, cross the equal line. Now, Anthony, what are your thoughts? Anthony, your seat's over here. Yeah, come on over. I think you better. Participation, Anthony, participation. I'm trying to just move the corner. No, very close. Do you want it? How do we want it? Anybody? It's actually very challenging. How do we get a lot alone? Does anybody have any ideas? Square it.
I was about to say square it.
Interesting idea.
So we're
Keep it coming. That's not it. Keep it coming.
Oh. You tell us to leave the 3 alone.
Okay. So I did switch x and y because I'm trying to find the inverse. So those are good. And then I minus the 4. Now the y is stuck up high. I love where you're at. The y is stuck up high. How do we get something stuck up high by itself? Put it out there. Dividing? No, but that's an operation.
Fraction.
Maybe
Did you say fraction?
I like how you're going with root.
Oh.
Alright, third root. Great idea. That won't do it.
Okay.
I thought of a y root.
See, that's the thing.
Right? Maybe a y root. But the problem is if I do a y root on both sides, yeah, the y is Alright, all very, very good ideas, guys, but what we have here is an exponent. What operation will solve for exponents? Logarithm solve for exponents.
Of course, I did not want to.
And you said take log of both sides, and I said you're very close. You're right. I'm not gonna actually in our when we're solving, we do take the log of both sides. Here, when I'm just trying to go out, I'm not taking the log of both sides. I'm just gonna convert to log form. And maybe that's what you meant. Maybe you knew. That's what you said.
I said that after.
Okay, great. Very good. So we're gonna convert this to log form because logarithms solve for exponents. So wait. How do you do a log? You have to write the word log. I'm gonna pause and let you guys go from there. Try to put that in log form. What's the base going to be? What's the argument? What's going to be next to the equal sign?
It's not fair.
Libby, what's the base?
Basic 3. Yeah.
Alright, base of the exponent is the base of the log. I know logarithms solve for exponents, so the exponent will be next to the equal sign. So what the argument is actually x minus 4. Log base 3 of x minus 4 equals what? This is a successful inverse. I want to remind you, when we practiced inverses, we showed them with this little f negative 1x. You guys remember that little negative 1 thing?
No.
It was before whenever, so it's been a long time.
That's why.
Alright, so now that I know I need to graph a log. So number 3 says graph the inverse on the same coordinate plane. So for number 3, you're going to start without the minus 4. You'll just graph the log base 3 of x. So try to remember, how do you make a table to graph a log? Does anybody remember the table for log graphs? You do the y's instead. You do the y's instead. So, in exponential, our x is meant like this, but the strategy for logs is to do your y values. And then I said, well, after you do that, you want to consider the exponential form instead of the log form. So we're going to do 3 to the y. And remember, we practiced, we plugged numbers in for the y value. What I'm going to do is just move everything right 4. Now, from here,
What is the purpose of
you could plug in here, negative 2, negative 1, 0, 1, 2, and then subtract 4 from each of these results. You know, if you like that method better, but what I'm going to do is this is a horizontal transition right 4. So I'm going to use the transformation. All right, so this would be 3 to the negative 2 is x. That means 1/9 is x. 3, yes. You have the answer immediately. Switch the table. 1/3 is x. 3 to the 0 is x, so that's a 1. 3 to the first, and 3 squared. So, yeah, going back to your understanding of inverses, it's number 1, but the x and y's are flipped. Because that's how perfect inverses work. It's just x and y switch. So I'm going to graph the basic log, just log base 3, and then I'm going to do the transformation of that minus 4. So gosh, how do we do this? So x is 1/9. I really want this to be better. One third, 1, 0, 3, 1, 9, 2. So this is y equals log base 3 of x. So if you put a perfect diagonal in between these, the y equals x diagonal, these graphs are reflected diagonally. You got 3dx. You flip a diagonal, you got the log base 3 of x. So that's a good one. So now I'm going to take this and this represents a horizontal translation right 3. I'm sorry, right 4. I don't know why I said 3. So I'm just going to count every point to the right 4. 1, 2, 3, 4. There it is. Okay. So there's a lot of comprehension. This is a big visual what you're looking at here. Visual representation of inverses. So this is 3 to the x, and this is log base 3 of x. And this is 3 to the x plus 4, and this is log base 3 of x minus 4. So in the exponential, it was up 4. The inverse is right 4. Folded this way. So that's that, people. When you're done, you can open your book to the evens you did yesterday, and I'll show you those answers, or you can ask questions if you're trying to understand those. Do you remember what Thursday was? 6.6. Okay, so there's 3 levels of difficulty. First is the most basic. It's going to start out really straightforward, and the problem will show the same base on the same sides of the equation. This is your best case scenario. Something like this. 5dx equals 5 to the third. This is the same base on both sides. You would cancel the 5's out and x equals 3. So that'll be our most basic problem in this section. You're given the same base on both sides. The next medium difficulty is you don't have the same base, but you can create the same base on both sides. So if it's not given straight up with like 2 exact 5s, maybe it looks something like this. You know, where it's not exactly the same base on both sides, but you can see how you could make it happen. This one you would rewrite as 5 to the negative 1, and this one you would rewrite as 5 squared. So the most basic will visually will be presented as the same base. The middle difficulty is it's not the same base, but you can see how the same base can be created. You create the same base. And then lastly, it's just a whole other ballgame. This third level of difficulty is when the same base cannot be created, you must use a logarithm to solve for those exponents. So I think today we'll just focus on number 1 and 2, the basic and medium, and tomorrow we'll get into the more difficult where you're required to use the logarithm. Here's the examples we're going to do. I don't want to rush you. You need more time to read these. You just tell me to wait. Over here. Over here.
It's a little dry. Get up there. So bad. That hurts so bad. Thank you. I really appreciate you. How come you have it? I didn't know you would be there. I love it. Hey, what are you guys doing? What's going on? What? Come on, dude. Where are you going? Oh, I got the end of my leg. Those are the driest. No wonder you guys are such a good movie. Wait, why are we going? Oh, boring. Lucky duck. It's okay. Okay. Wait, no. I think it's just different. You're gonna have one leg in this room.
So we got base 7. When this is the most basic, what you do is you can just drop the base, and this is called equating exponents. Equate exponents. So the base is that. Drop on. I just put like a X through it. And then you're left with just the exponents equal each other. It's just a basic linear equation. I would subtract the X over.
I went in yesterday. They were like recommending and
Which one going?
Have you looked at the Manatee County like summer internships?
Yeah.
The Manatee County jobs, and I just saw this is for everybody. They're they do like it's trial and error.
Oh, okay. I love watching
Yeah,
kids.
pays like $14 an hour.
Oh, that's really low.
Well, but it's
you should be happy you're not getting paid 11
Guys,
at my job.
yeah.
but it's full time.
Full time.
Full time.
$14 an hour full time is gonna get you a lot of money.
Wait, full time meaning what?
Like each quarter.
Oh, okay.
And then it's called an internship, so it's like actual career-based hours.
During summer. Oh. How was that rude? It's during summer. Because you said it, Manatee County summer job. So I figured we heard the summer part. That's my bad. I didn't mean to sound rude. Or you can just work at live. Oh, that's your lot. You make a lot of money there. I make bank. I don't think I could take it up now to see
No, I don't know.
I work today, 3 days this weekend. 3 days this weekend.
Jobs.
Saturday, Sunday. I want to work at the
Summer camp at the Lions Gym. Oh, here it is, look.
Oh,
This one's
so
for
funny.
It's called Summer Intern.
Oh, yeah.
Look at all these internships, you guys.
What qualifications do you need to get?
Oh,
Do you need like a
Hey.
CPR training?
Sorry, I
Do you
didn't
just
mean to
take
cut
courses?
I love pickleball.
What's the Summer Intern for Engineering? I gotta click on that. Who does this?
wait, would this look good on a college?
Right, yeah.
Oh,
It's called
perfect.
an internship, so those is better. High school diploma.
Oh.
The what? These are all.
Is all of these going to have to be high school diploma?
No, somebody told me they did this. I heard from a freshman.
One of the children's services.
Freshman was taking care
Oh,
of
shoot.
children?
Yeah, they were 14 and they had a summer internship over the summer and they was.
What is their qualification? They like barely turned.
No, this is the people who haven't worked before. I'll find out. I'll find out what that is.
Yeah. This is child parenting in
Y'all
Ohio.
just learned how to cook eggs.
I still don't know how to cook eggs.
Still don't know.
That's the only thing I can cook and I'm allergic to.
Alright, let's do number 2 real quick. So,
Piece of toast.
number 2, we don't see a big base 2 on both sides, but we can create the big base 2 on both sides. So, the issue is people think they make the 2 turn into an 8. That's like the big mistake students think. What you do is you make the bigger numbers smaller. Okay? So I'm going to make this 8 smaller. I'm not going to take the 2 and the 8. I'm going to bring the 8 down to the 2. That might not make sense right now, but eventually it will. 8 is the same as 2 to the 3rd. So I got to use that little fact. 2 to the 3rd is 8. And I'm going to pull a replacement. So I'm taking an 8 out, and I'm putting 2 to the 3rd in, which they're equivalent, so that's fine. Alright, so then I'll use the properties. I will distribute. That's the power property, distribute. That makes it 6x minus 3. And now we're back to same base. You go right back to what we did on number 1. You can drop the base and equate exponents. And then you have like a kind of a really basic equation to solve from there. Put your line in, I would subtract the 4x. And then I would add the 3. 2x is -1. And that's -1/2. So that's it. That's what you're doing today. These are your 4 problems. 3, 4, 6, and 8 in chapter 2. Oh,
609.
609, thank you. Anyway, yeah, a lot of summer camps and stuff are hiring right now for summer. They hire in fall.
See, I feel like I'm really proud of that.
Right,
There's so many camps that I'm doing, so many
workouts. Right. We have pictures. I can't even work at full time.
I don't think much is. I need some
Really,
money
what
because I'm tired
solution?
of finance. Yeah.
My friend works at somewhere like I have two different jobs.
Because they have more in the summer too.
But I got